The last section that we have for this chapter is section 1.6b, absolute value inequalities. And so we're going to focus on combining absolute value equations, which we did yesterday, with compound inequalities from 2 days ago. And so it's important that we find a way to understand what these problems are asking us to do. And this first box kind of helps us break down absolute value inequalities into a more meaningful topic that we can understand. And so this first one says that if you've got the absolute value of something and it's greater than a number, so the absolute value of something is greater than a number, we're talking about extremes. We want the distance from 0 to be larger than something. So we want it to be really far from 0, really far to the right or really far to the left. And so this ends up being an or inequality. One way to think about it is as great or than, right? This symbol is greater than. And so we want the distance, absolute value is distance, to be larger than some number. So those are the extremes. And so we know that those are the types of inequalities that end up being graphed towards the outside. Those are our or inequalities, something like this, okay? If the reverse is true, if it's a less than symbol, then we want the distance from 0 to be smaller than a number or within a specific range. And that's how we end up with these and inequalities. Remember, this 3-part inequality is an example of an and inequality. And sometimes we use less and as a way to remember that. So if it's a greater than symbol, it's going to be an or inequality. And if it's a less than symbol, it's an and inequality. For and inequalities, if you remember, when we graph them on the number line, they are going to be between 2 points. So that's when we would graph between the points. So or is the extremes. We want to be farther away from a number, or from 0. Here we want to be closer to 0. So let's take a look at what that means. For number 5, it says the absolute value 2 is greater than the absolute value of d. Now again, I prefer to have my variable on the other side, so I'm going to rewrite this as the absolute value of d is less than 2. Remember, we continue to open towards the 2, so we switch the direction of the inequality. So this is a less than symbol. So my absolute value is on the left, and I have a less than symbol. So this is an and inequality. I want the distance away from 0 to be less than 2. So I'm going to put 0 here in the middle, say 2 and then 4. So I'm really counting by ones. Here I do -2 and -4. And so I can rewrite this as an and inequality. And so what I want you to pay attention to is that my d's should be between -2 and 2. So -2 is less than d is less than 2. This portion of my inequality looks just like this one, except I've taken off the absolute value bars. And I can do that because I've accounted for the other solution. So in this case, I have open dots, open dot here, open dot here, and I'm going to shade in between because it's an and inequality. If I wanted to do interval notation in this situation, I would do parenthesis -2 to +2, because as I read my graph from left to right, I can't include 2, so I use the parenthesis, or -2, so I use the parenthesis, and we're going all the way to 2, and so I'm going to close that with a parenthesis instead of a bracket. So I've got graph, solution, and interval notation. So let's try something very similar for number 6. Again, my d is on the right side, so I want to move this absolute value inequality around. I'm going to say absolute value of d is greater than 3. Remember, we're opening towards the d here, so I'm still opening towards the d. And then this is saying that I want the extremes. I want the distance from 0 to be larger than 3. So I need those extremes. So if this is 0, I've got 1, 2, 3, 4, -1, -2, -3, -4. So this would be an or inequality. This is a great or than. So I've got d is greater than 3, but the other extreme I have to switch the inequality. d can be less than -3, and this is an or inequality. Okay, so in that case, I would have an open dot here at 3 and shade towards the outside. And I've got an open dot at -3 and shade towards the outside. In interval notation, that would look like -infinity to -3, all with parentheses, or +3 to +infinity. all with parentheses. I didn't have any equal to symbols, so I have no brackets in this situation. So here's my interval notation, here's my solution, and here's my graph. I want you to go ahead and try numbers 7 and 8 and see how you do with those. You're welcome to check your answers on the notes that will be posted on the class website. But let's flip to the back when you're finished and take a look, please, at example number 9. So example number 9, it gets slightly more complicated, and so we want to take a look at what that means for us. It says the absolute value of 2x minus 2 is greater than or equal to 4. Greater than or equal to, so the distance from 0 is greater than 4, so this is an extreme, this is an or. We want to be outside and further from 0 than 4 spaces away. And so I have an or inequality here, and so I'm going to rewrite it as an or. So one of those ors is 2x minus 2 is greater than or equal to 4. I just ignored the absolute value bars. My other alternative is or 2x minus 2 is less than or equal to negative 4. So I switch this inequality and I switch the sign. So those are my extremes. This one will open to the right, this one will open to the left. I'm going to solve both independently of one another. So I'm going to add 2 to both sides. I get 2x is greater than or equal to 6, and when I divide by 2, I get that x is greater than or equal to 3, or whatever I get over here. So add 2 and add 2. I get 2x is less than or equal to negative 2, divide by 2 on both sides, and I get x is less than or equal to negative 1. I'm kind of sneaking in the space here. Okay. So these numbers don't have to be the same because of all the things that were happening inside the absolute values. But I knew this was an or inequality because I wanted something further away than 4 spaces. So now I can go ahead and set up my number line. So I've got 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. I've got a closed dot at 3, and I'm opening to the right. This is an or inequality, so it should be the extremes. And I've got a closed dot at negative 1, and I know that these are both closed dots because they have the equal sign underneath, and this one is shading to the left. The last piece that I would need to do here is to write it in interval notation. This is going to go from negative infinity, remember infinity's always got a parenthesis, to negative 1, and this gets a bracket, and it gets a bracket because it's a closed dot and an equal sign, or bracket again because I've got or equals to, 3, parenthesis, positive infinity, close the parenthesis. So I've got interval notation, solution, and my graph, all 3 pieces of information. Go ahead and try example number 10 on your own. You're welcome to check your answer on the website, but we're going to look at the word problems together in class, so there's no need to do those now.